Hello, my name is Zheng from the psychology department. Today I want to tell you how we can improve visual learning through spatial alignment, in particular through a better design of the learning materials. When I was in middle school, I really didn't get to enjoy those traditional STEM. They're hard and abstract. For example, maybe you remember those complex diagrams of electric circuits or chemical molecules. Now, as I study cognitive psychology, I have the opportunity to revisit the question of what makes the classroom learning hard. Before I share my answer, I want to play a game with you to illustrate this. So for each trial, you will see two simple images, and I want you to unmute yourself and tell me whether they're the same or different. If you prefer, you can also say it in your heart. Are you ready? Let's do this.
Same.
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 Great. So in both cases, the two have the same patterns. However, you may feel the one on the left is easier to do than the one on the right. Why is this the case? It turns out that in comparing two things, we need to first align the individual elements to elements correspondingly. And in comparing visuals, we are doing this based on spatial locations. So we align the first to the first, the middle one, and the last one. After the alignment, we can then compare the underlying patterns. The same thing on the right. However, the correspondence is harder to draw here as you have to cut through other elements to arrive at the alignment. This is like when you're in traffic, it's hard to see what's going on before you because there's a car intervening in between. But now suppose you're interested in the traffic next to you, it's easier to see because now you're standing parallel to the traffic line and has a clearer view. This is essentially what our mind is doing when we compare visuals, and we call this the spatial alignment principle. When alignment is direct, the comparison is straightforward, and so learning becomes easier. The reverse is true when alignment is impeded. This principle can also be used as a design principle. We can facilitate learning by making the materials directly alignable and avoid cases where the alignment is impeded. My ongoing work is trying to apply this principle beyond simple stars and shapes and colors to the real textbook diagrams and images. This is because visual comparison is a principal way of classroom learning. So the takeaway is how things are put together matters for how we process them. So why not make this process enjoyable and benefit our learning in the classroom? Thank you.